Now we're going to continue to talk about radians. In the previous video, I realized that when we were talking about radians and describing that, I basically said, well, if we have a circle and if we start here at 0 and we go all the way around, that would be equal to 2 pi, or if we went halfway around, that would be equal to pi. And now in this video, I want to take a little bit of a time to explain where this idea of radian comes from and a little bit more in depth of the definition. And at first, if you don't understand this, don't panic, but I'm just trying to explain where this is coming from. I know for most of you, you think that when it comes to math, all these different formulas are made up. So I want to take a little bit of a time here to explain where this concept is coming from. And to do that, the radian is coming from the idea of the formula here. I'm going to use the Greek letter theta, which is our typically used to represent our angle. And theta, the angle is going to be equal to S. Okay, and here we have the letter S, which is going to represent arc length. And if we take that and divide by R, which is the radius. Okay, so if we look over here to find the angle theta in terms of radians, r is the radius. So if we go out here, the radius r is for the circle. Then the arc length is the part over here that goes all the way out. So this is representing the arc length, and I'm really not sure why we use the letter S, but that's what they use. So S is representing this arc length. And of course, then our angle is theta. And the way we define this, if we take the radius and divide it by the arc length, that's going to give us the angle in radians. So whereas we can measure the angle in degrees, such as 10 degrees, 15 or 30, 40 degrees, then in order to find the radian, it is simply taking this arc length divided by the radius of the circle. So for an example, if we were to have the arc length, let's say that let's make another example here. Let's say that if we have the given circle and we have an arc length that starts here and goes all the way around, and let's say that this is 6 feet. Okay, so this curve, which is the arc length, that is 6 feet. And we know that the radius, if we go out to the circle, the radius here is going to be equal to 2 feet. And we want to calculate what is this particular angle here for theta. Well, we know from before the angle is going to be the arc length, which is 6 feet, divided by the radius, which is 2 feet. Now, if you recall in the previous video, I said that the radians really did not have a unit, and that's because here, once we divide 6 divided by 2, that's going to obviously be 3, but notice here, feet divided by feet, these units are going to cancel out. So here, the angle in radians is simply 3. And again, that comes from simply taking this particular arc length divided by the radius. And if we look at this closely, if I drew this a little bit better to scale maybe, if this tells us that this here is 3, let me redraw this. This probably would have been a little bit better if I said the arc length went, let's say this probably would have been a little bit better for 6 feet, and the radius would be here, which was 2 feet, and we're saying this is equal to 3. So that tells us that if we go all the way around to here, this is 3 radians. So if this location is 3, remember, what did we say that halfway around here was? Well, we said if we went halfway around here, that would be equal to pi. Well, remember, pi is approximately 3.14. So if we have an angle that is 3 radians, then we know that we're almost halfway around, because here to pi is equal to 3.14. Okay, so all of that stuff we talked about before is going to still be true. We just looked at everything in terms of pi. So here we're simply using the number 3 because we simply take 6 over 2, which is equal to 3. All right, so that's the definition of how we would find all of these radians. It's simply taking the arc length divided by the radius. Now, let's look at if S is equal to R. In other words, if the arc length is equal to the radius, if S is equal to R, then the angle theta would be what? Well, if we have our circle, if this is our arc length, and if this is our radius, what do you think is going to happen? Well, if these two values are the same, again, we know that theta is equal to S over R. So that means here then, if they're the same, so let's just pretend here for a second that both of these are S equals 2 and the radius is equal to 2, then we would have 2 divided by 2, which means they're the same. So therefore we have theta equals 1. So that tells us this here is 1 radian. So that's how we define 1 radian, is simply when S and R are the same. Now the reason this works is because no matter what circle it is, if you make the circle smaller, then that means the radius is getting smaller and with the idea of the arc length. So no matter the size of the circle, the radian is defined as S over R. Okay, so now let me try to explain if we know that theta is equal to S over R. This is where I really want to try to explain where this idea is coming from. If we have a circle, and I'm sure that you probably can tell me if I said, what is the distance around this circle? In other words, if we start here, and if you remember what is this term called, if we go the perimeter of a circle here, we're talking about the circumference. So all the way around this circle is the circumference. And if you remember, the formula for circumference is 2 pi r. Okay, so this is all the way around. Well, if we think of this in terms of up here, this is kind of like the arc length, but when we think of 2 pi r, this is the arc length, but this is for the entire circle. Okay, so if we think of this as the arc length for the entire circle, then here we're looking at the circumference. Because if we go up here, remember this little piece here is the arc length, but now if we go all the way around, we can kind of think of that as going all the way around the circle. So if that's representing the arc length, we would then have our angle is equal to the arc length. Well, the arc length therefore is 2 pi r. Okay, so there's the circle. The arc length is this whole circle. And of course, what do we divide by? We divide by the radius. Well, the radius of the circle we know is going to be r. So if we divide this by the radius, we have 2 pi r divided by r. And since this is all multiplication division, the radius will cancel out. And we find that theta is equal to 2 pi. Now, doesn't that fit what I told you in the previous video? If we were to go all the way around the circle, the angle is 2 pi. Okay, so now remember here, the arc length or the perimeter around, we're actually measuring the distance around. And when we think of the angle, then we're looking at dividing this up into the, whether it's degrees or radians. So the angle around is equal to 2 pi, and therefore, of course, if we take half of it, we would have 1 pi. So this hopefully over here will give you an idea of where the idea of 2 pi and pi comes from if you think about it in terms of using the formula for circumference, which is 2 pi r. So once again, if you don't completely understand this explanation here, that's perfectly fine. Again, maybe you want to come back and review this again, but I just wanted to kind of show you where all of this is coming from, and just instead of saying that all the way around the circle is 2 pi, halfway around is pi, then of course, if we went up here to the top, we define this as pi over 2. It's really coming from the idea of the radian is the arc length divided by the radius here, and of course, if we take the complete circumference, the complete circle, that arc length is 2 pi r divided by r, and that's where we get the 2 pi from. Now, most of the time, we're going to represent our radians in terms of some multiple of pi, just like in the previous video where we marked off things as pi over 3, pi over 2, pi over 4, but it won't always be in terms of pi. For example, if you have the circle and we could identify, for example, this as 0, we said this is pi. Well, instead of pi, we could say that is approximately 3.14. Okay, so it's okay to use just strictly numbers, but again, in most situations, we're going to use things in terms of pi. Just like we're going to normally call this 2 pi, whereas this would still be the decimal of approximately 6.28 because 2 times 3.14 is 6.28. Now, in most cases, we're not going to say 6.28. We're going to simply say 2 pi. Now, there are cases where you'll see the decimals used. Now, let me go ahead and kind of mark these off, and this is something you'll definitely want to be aware of. If we're thinking of radians, 1 radian is where the radius and the arc length, remember, is the same. So if we take, remember, theta is equal to s over r. So 1 radian is where s and r are equal. So I'm going to kind of estimate this. So that's going to be approximately right about here. So this radius is about the same length. So this distance is about the same as the distance here. So this point on the circle would represent simply 1 radian. Okay, now don't confuse that with over here where we got 3.14. This is 1 pi, and 1 pi is 3.4 radians. But up here, this is simply 1 radian. So if I went around and if I take and mark off this distance all the way around, whoops, erased too much. So if this distance here of 1 radian, if I was to mark off that distance again, that same amount, then here we would have another radian. So at this point, this would be then 2 radians. And if I kept marking off that same distance, we already said before from the previous circle, we know this is going to be 3 radians because it's almost all the way around because pi is 3.14. And then over here we would have 4 radians, 5 radians, and once again, ever so closely here, we're going to have 6 radians. So 6 is not quite 1 circle around. And then, of course, if we keep on going around the circle, we would just keep on going. So again, 2 pi, 6.28 would be 1 circle. And if I said, where is 7 radians? Well, of course, then if we went to 7 radians, we'd be back up here. And then we could go to 8 radians, 9, 10, 11, and all the way back around. Okay. Then, of course, now, if we were going negative 1 radians, then we would be going in the other direction. So keep that in mind. All of these are positive, so keep in mind this is the positive direction, and if we were going this way, it would be negative. So this is a circle you might want to kind of be somewhat familiar with as far as remembering where 1 radian is, 2, 3, 4, 5, and 6, just somewhat as a reference as the location. All right, so let's look at some examples of how can we locate, if I said theta is equal to 3 pi, where is that located approximately on this circle? Well, there's a couple ways we can do this. We could certainly just count. We could say, well, we know we're going to start, this is 0, this is pi. We know all the way around here is 2 pi. So if we're looking for 3 pi, then that means we need to go around again. So 3 pi is going to be at the exact same location as 1 pi. Well, and if you keep on going around, what happens if we come around? That's 3 pi, then that means this would be 4 pi, and then if we go over here, we would end up with 5 pi, and then over here we would have 6 pi. So let me see if you notice a little bit of a pattern here. If I gave you this angle, and I said, where is the angle 127 pi located? Well, you could certainly count, but you're not going to want to be here all day and say, well, we start at 0 and this goes to 1 pi, this then is 2 pi. But if you notice, what do we see about all these 2 pi, 4 pi, 6 pi over here? And over here we have 1, 3, and 5. If it's an even multiple of pi, a nice even multiple 2, 4, 6, it's going to be over here. So if we notice, our number is odd. So that tells us 127 pi is going to be located here at the same location as 1 pi. Okay, what happens if I give you the angle theta is equal to a negative 3 pi? Well, that simply means if this is 0, it's negative, so we're going to go this direction. So this is negative pi. This then would be a negative 2 pi. And if we go back around here, we're at a negative 3 pi. So that's the location of a negative 3 pi. Because remember, this direction, we have to go for a negative angle. All right, so let's see if we remember from the previous video. We talked a little bit about splitting up our pi here, dividing the circle. So if I give you the angle 5 pi over 7, how can we locate that angle? Well, keep in mind, we're wanting to divide what into 7 equal parts? We're not dividing the whole circle into 7 equal parts. We're only looking at this top part. So once again, ignore the bottom part of the circle. So we want to think about dividing this into 7 equal parts. Well, 5 pi over 7. Well, the question is, you can kind of think of just the fraction, and I know this is everybody's favorite, fractions. Like I said before, if you don't like fractions, you better learn to love them because we're going to be working with them quite a bit. Is 5/7 bigger or smaller than a half? Well, if we think about dividing this up, because now 7 is not a nice even number, so this isn't going to divide up right in the middle perfectly for us here. But if we think about this location here is pi over 2, so that's a half. And we know that 5/7 is bigger than a half. Okay, so therefore 5 pi over 7 is going to have to be located right about here. Or at least you should know that it's going to be somewhere over here in the second quadrant. Okay, and that's because if this is 5 pi over 7, keep in mind that right here is pi. Well, if this is pi, then that means this would be 7 pi over 7 because 7 cancels and that's equal to 1 pi. Okay? All right, so let's see if you can figure out this next one. And again, here you may want to actually pause the video and see if you can come up with the answer. If I give you theta equals 8 pi over 7, where is that going to be located here? Is it going to be in the first, second, third, or fourth quadrant? So that's kind of the first thing you want to determine. And then maybe you can kind of guess a little bit better, where is it going to be located in that particular quadrant. So maybe pause the video and see if you can figure this one out. All right, hopefully you were able to work on this on your own. Again, I use the same denominator 7, so again, we're dividing the top part into 7 equal pieces. Well, if you notice here now, we have 8/7. The top number is bigger, so that means we have an improper fraction. So what you may find helpful here is change this to a mixed number. Well, if we take 7 into 8, that goes once, and we have 1 left over, right? If you take 7 into 8, that's 1 time, and you're going to have a remainder of 1, so that's going to give you 1 and 1/7. So this is the same thing. Uh, Mentally, you may think of it this way. You're not normally going to write the angle this way. We're normally going to write it as 8 pi over 7. But if you mentally think of this as 1 and 1/7 pi, then we know that all the way over here is 1 pi, and then we need to go 1/7 more. So that tells us we're going to be here in the third quadrant for 8 pi over 7. And you can do that pretty much with all of these radians. So if your fraction is not like the 5 pi over 7, where this is a nice proper fraction, we know that this value here is less than 1, so therefore we know that it has to be in the first or second quadrant. So then all we have to determine is this fraction more than a half to be in the second quadrant, or is it less than a half, which means it's in the first quadrant. So if you have a proper fraction, it's going to be first or second. If we have an improper fraction, we know it's going to be something bigger than 1. So let's take a look at another one here. If we have theta is equal to 25 pi over 12, well, that means we're dividing everything into 12 equal parts, but again, this is an improper fraction, so let's divide this. 12 into 25, that's going to go 2 times 12, which is 24, and we'll be left with 1/12. So now we have 2 and 1/12 pi, so we can kind of mentally think here is 1 pi, 2 pi, so here's 2 pi, but then we need to go another 1/12 pi. So that tells us our angle is going to be here, which is in the first quadrant. Okay, so hopefully you can kind of get the hang of this so that you can locate where this angle is. So I know a lot of times if you say 25 pi over 12, right at first glance, I don't expect you to memorize that off where that location is, then you can certainly just divide this. Now, in that previous video where we went through pi over 4, pi over 3, pi over 6, those are the ones that are kind of your common special angles, and those are ones that you definitely want to be very familiar with. But these other ones that have different denominators, such as the pi over 7 or this 25 pi over 12, then think of these values as mixed numbers, and then we know where 1 pi is located, you know where 2 pi is located, so therefore we can just kind of from there determine how far to go around the circle. All right, so I hope this explains a little bit more about radians and as far as how we can locate a particular angle. And once again, at some point, if you didn't follow the explanation, go back to this and remember that the radian here is defined as the angle is the arc length divided by the radius.